Welcome to my channel. In this video, I'm gonna explain about the topic real zeros of polynomial function. Let's start our video. We know that what is polynomial? Polynomial means it's in the form of a1 x power 1 plus a2 x square plus etc plus an x power n. This is the format of polynomial, right? Okay, what is the simplest form of polynomial? How we can write that is f of x equal to a into x power n, right? I will ask one question. What is the degree of quadratic function? We just discussed in the previous video. The degree of the quadratic function is 2, alright? Okay, let's start our video. That is, first one is factor theorem. I just explain about the factor theorem. A factor theorem means this is a statement of the factor theorem. This is a statement. A polynomial f of x has a factor x minus k if and only if f of k equals 0. That means the meaning of this theorem is, the statement is, if any polynomial f of x, the f of x may be a quadratic function or linear function, whatever it may be, it's on polynomial. This polynomial has a factor x minus k. Okay, this polynomial has a factor x minus k. That means if and only if f of k equals 0. Okay. Again, we can write in a converse also. If f of k equal to 0, we can write the polynomial f of x has a factor x minus k. That means it's nothing but if you put x equal to k into this polynomial, that is f of x polynomial, you get an answer f of k equals 0. That is the factor theorem. Okay, I hope you understand this. Here one example related to this factor theorem, that is f of x equals 5x square minus 9x square. This is plus 6x. Okay, plus 6x minus 2 has a factor x minus 1 since f of 1 equal to 0. That means here this is a polynomial. F of x is a polynomial. Sorry, this is cube. Okay, this is cube, 5x cube. This is one polynomial. This has a factor x minus 1. That means according to the factor theorem, we can write f of 1 equal to 0, right? If we put x equal to 1 into this polynomial, you get the answer f of 1 equal to 0. I hope you understand this. Here the factor is x minus 1. That is x equals 1. I hope you understand this. Let's see another example. Here is one example. Use the graph and the factor theorem to list the factors of f of x. The graph is like this. Okay, here this is minus 2. This point is minus 2. This point is minus 2, and this point is 1, and this point is 3. Here we need to identify the factors of f of x, right? They didn't give any polynomial, they just give on graph. That means we just identify the factors. That's very easy because the factors means f of any value that is equal to 0, right? If we give 1 here, the value of x equal to 1. Right? That means the factor is x minus 1. You must identify the values of x only. So, you just see in the x-axis. What are the values are here in the x-axis? Wait. See here. I explained in the previous slide the graph is in the minus 2, 1, 3. So, the graph zeros or x-intercept of f for minus 2, 1 and 3. That means if you write f of minus 2 equal to 0 by the factor theorem states that x plus 2 is a factor. And f of 1 equal to 0, that implies x minus 1 is a factor. And f of 3 equal to 0 implies x minus 3 is a factor. There are 3 factors. Okay, I hope you understand this example. The another topic, that is complete factored form. What is complete factored form? Here is one polynomial, that is f of x equal to a n x power n plus etc plus a to x square plus a1 x plus a naught has n real zeros c1, c2, etc. cn. where a distant 0 is listed as many times as its multiplicity. Then f of x can be written in complete factored form as f of x equals an of x minus c1, x minus c2, etc. x minus cn. This means a complete factor form is if here is one example polynomial is here and the real zeros are c1, c2, etc. cn. Maybe there is some common values. That means if 2 is common here, that means we take 2 as common in that polynomial, from that polynomial, okay? That is, we can written as the common value. Here we take an is common and we can write the factors. They are giving the real zeros, right? That means x equal to c1. That means x equal to c2, etc. x equal to cn. We can write like this. An of x minus c1, x minus c2, etc. x minus cn. Okay, this is called complete factored form. Let's see one example related to this. After that, you can easily understand what is complete factored form. Here is one example. Write the complete factorization of the polynomial. Here a7x square minus 21x square minus 7x plus 21 with given zeros minus 1, 1 and 3. They are giving a 0. That means here the minus 1 is here. Then the factor is x plus 1. Okay, 1 is here. Then the factor is x minus 1. 3 is here. Then the factor is x minus 3. Complete means complete factorization of the polynomial. Here, what is the leading coefficient? What is the common value here? That is 7, right? This is the answer. Okay, the common coefficient right in the first and again the zeros. That is x plus 1, x minus 1, x minus 3. Okay, I hope you understand this example. Another one example is here. That is one polynomial is here and as zeros of minus 1. The polynomial has a 0 of minus 1. Express f of x in complete factor form. We need to express this f of x as a complete factor form. Okay, they are giving a 1 0. The 0 is minus 1. By using a synthetic, minus 1 means what is the factor of minus 1? That is x plus 1, right? Here the x plus 1 is a factor. Just check whether this x plus 1 is a factor. By using, whether you put x equal to minus 1 here, it becomes equal to f of minus 1 equal to 0. Just we use a synthetic division here, okay? That means put minus 1, that is 2 minus 34. Okay, first I explain here minus 1. 2 minus 2, we just write the coefficients of this polynomials. Minus 34 minus 30. Just you write 2 into this minus 1, that is minus 2. Minus 2 minus 2, that is minus 4. Minus 4 into minus 1, that is 4. Minus 34 plus 4, that is minus 30. Minus 30 into minus 1, that is 30. We get the remainder as 0. Okay, that's only here. There's only this here. The remainder is 0. We can write x plus 1 into this. Okay, that is equal to, by using a complete factor form, right? So we can take 2 as common here. If we take 2 as common, what do you get? 2 as common, we get x square minus 2x plus 15. See the factor. What is the factor of this? If we multiply, we want to get 15. Okay, if we add, we wanna get minus 2. Okay, that means minus 5 into 3, right? Minus 5 into 3 means it's plus 5. Oh my god. Wait a minute. Here is minus. This is minus. Then we can write plus 5 into minus 3. Okay. If we multiply this, we get minus 15 If we add this, we get 2. Okay. This is minus. So this is minus x minus 5 into x plus 3. Okay, let's see here. We take 2 as common, right? 2 as common means we can write 2 into x square minus 2x minus 15. That is equal to 2 into, we need to get minus 15. If we multiply, we get, we want to get minus 5, and if you add this 2, we need to get minus 2. What the two values we can write? That means 3 into 5 equals 15, right? Okay. 3 into minus 5. Okay. 3 into minus 5 equal to minus 15. 3 minus 5 equal to minus 2. We got the answer. That means we can write x minus 5 and x plus 3. I hope you all are understand this. Just I recall once again, in this video we discussed about the zeros of the polynomials. First we discussed about the factor theorem. Factor theorem means if the value of a factor, the polynomial f of x, and the factor of the polynomial is x minus k, then if and only if f of k equal to 0, right? We see some example later to that, and again we see complete factor theorem, and I hope you all are understand these topics. Okay, thank you.